Okay, Happy New Year, everyone, and welcome back to another video. Today we'll be covering how to do Quicksort. So, Quicksort is a sorting algorithm that lets you sort an array. Usually, you would sort integers, but you can use it to sort any object if you have a comparable and things like that. And basically, how you do Quicksort is there's three main steps. The first step is that you need to find a pivot to you just choose a random index, or it could be the first element, it could be the last element, it could be the median, but choose one of those, and then you can set it as your pivot. Then what you do is you need to sort the elements in the current array so that the elements smaller than the pivot or equal to the pivot is going to be left of the pair of the pivot, and then the elements larger than the pivot is going to be to the right of the pivot. Now this is sorting in ascending order. If you wanted to sort in descending order, then you would just put the smaller elements on the right and the larger elements on the left. So then the next step is after you sort the array or rearrange the array, you would use recursion to sort the array left of the pivot and then the array right of the pivot. And after you do that, and then after the recursion finishes, you'll have a perfectly sorted array in your order. So if we go down over here, we can see how we do this. All right, so let's just say we start with an array that's 10, 20, 5, 1, 30, and 15. So we're going to choose the last element as our pivot for this video, just because why not? But basically, we choose the last element as our pivot, so 15 is our pivot. And what we want to do is we want to go through this array, and we want to choose the choose the smaller elements and then put it on the left of 15, and get the bigger elements and put it on the right of 15. So as you can see here, I've sorted it so 10, 5, 1 is smaller than 15 and it's to its left, and 20, 30 is bigger and it's to its right. So then we sort this section, and then we sort this section. So then we come over here, we choose 1 as our pivot. Then we have 1 is on the left most element because it's the smallest, and 10 and 5 are both to the right of 1. So then we sort this array over here, which is basically nothing, and then we sort this array right here. So over here we choose 5 as our pivot. So then we move 10 to 5's right, and then we sort 10. So then obviously 10 by itself, it's just 10. So then we have 2 empty arrays, and the left side of the array is now finished. Now if we move to the right side, we set 30 as our pivot. So then we have 20. So then we sort 20, and then we only have 20 left. So it becomes 2 empty arrays. And as you can see over here, if I get rid of some markings, our ordering is 1, and then we have 5, and then we have 10, and then we have 15, and then we have 20, and then we have 30. So then it'll be 1, 5, 10, 15, 20, and 30, which is the sorted array. Now, what you want this to do is that since you're randomly picking a pivot, we basically the expected amount of times we have to sort this is going to be log n amount of elements in your array. But since like the array could be ordered very badly, and if we have to sort every single time, then this becomes n. So in average case, you want to have the sorting take linear time, so then the final complexity is n log n. But then usually, or sometimes, the worst case is that you have to sort it n times 2. So then the worst case scenario becomes n squared. So that's the expected runtime of Quicksort. So now we just have to cover how to sort it in linear time. So basically, rearranging the array in linear time is needed to provide a fast runtime, and we have an example here. So if we want to rearrange this array, this is just the initial array that we had in the previous example. So our pivot is still going to be 15. Then what we need to do is, let's just draw a new array right here. Okay. So what we need to do is we need to put the smaller elements to its left, larger elements to its right. So then what we have is, first, this 0th position is empty. So then, and then we also compare 10. So 10 is smaller than 15. So what we do is we swap 10 with the 0th position. So then basically that's swapping 10 with itself, so we still have 10. Then our position is here. And then we're like, okay, 20, that's bigger than 15, so we don't do anything. Then we go to 5. Okay, 5 is smaller than 15. Then we swap 5 with the 1 position, right? So then we have 5 here. And now 20 is in 5's position. Then we move to 1. And then our current pointer here is at 2. So we're like, okay, 1 is smaller than 15. So we swap 1 again with the 20 because 20 got moved here. So now 1 is here. And then we see that 30 is still bigger, so it doesn't matter. Then we swap 15 with whatever is in this position, which also turns out to be 20. So 15 becomes here, and then that's 30, and that's 20. And then, so now as you can see, everything on this side is going to be smaller than 15, and everything on this side is going to be bigger than 15. So basically, what we do is we loop through the array. As we find an element that is less than or equal to the pivot, we store it incrementally up in the array, swapping elements if needed, which is always needed. So then, as you finish the operation, what you're left with is a perfectly rearranged array that you can perform quicksort on. So now if we go to our code here, what we have is we have a class called quicksort, then we have a private integer array. And in that array, so we have our constructor here, which is going to be going to store the user specified array in our class or class variable here. And then after that, we have a sort function. Basically, this is just to sort it from 0 to array.length -1. And then our quicksort algorithm is mainly here. As you can see, it's pretty short. So as the left pointer is, or the low pointer is still smaller than the high pointer, we want to keep sorting the array. So we want to get the pivot value. So if we go back to here, we need to get this index so we can have it go from 0 to this index -1. And then we also want to sort it from index +1 to the end of the array, right? So that's why we need to get the index. And then this get pivot also rearranges the array and returns the index. And then we do our quicksort from the lowest point to the pivot index -1. And then from pivot index +1 to the highest index that we have in our current sort. Then what we need to do is in our get pivot function, which is the main function, what we have is that we're going to start storing our values incrementally up. So at first, we're going to start at the start of our interval, which is the low pointer. And as we loop through the low pointer to the high pointer, we want to check that if the current element is smaller than h, the element at h, which is the pivot because we're choosing that last element as our pivot. Then we want to swap this value with the current element at j. And then we have plus plus at the end, so after it swaps I, it'll add 1 automatically to I. Then basically what we do here is that once we've swapped every single element that is smaller or equal to, we need to swap the pivot with the next available slot. So we swap the pivot with the next available slot, and then we return the index of the pivot. And then over here is just a swap function. Basically, have a temp, you set A to B, and then you set B to temp. And then lastly, we have a toString function, which is just to print out the array after we sort it. And right here we have an example. So if we take in this array, 10, 80, 30, negative 4, 93, 90, 40, 30, 10,000, 50, negative 10, 70, and 10, and we sort it, we'll have a perfectly sorted array. Let's wait for it to run real quick. So yeah, so then we have negative 493, negative 10, 10, 10, 30, 30, and then sorted all the way to 10,000. And if you want to change it, like if we just want to sort 10, 80, 30, then this would also work. So 10, 30, 80, right? So that's also sorted. So that's basically how you do quicksort. This algorithm is a little bit slower than merge sort because, well, average runtime it's the same, but in reality it's going to be a little slower because the worst case runtime is actually n squared, while merge sort is always n log n. But that's how you implement quicksort. I hope you enjoyed the video. Make sure to subscribe to my channel and give it a like. And thank you.